Okay, so I just did a few minor things to the schematic, and what I pretty much did was I went ahead and just wrote 555 time over here. The way you can do that is there's an option right here for text, and you can go ahead and click it, and you can type whatever you want. So I'm going to just, just like say George or something like that. And you can go ahead and just click again, and you can go ahead, and now it's a text thing that you can go ahead, if you go to default mode, you can go ahead and move around, and go ahead and delete if you need to. So that's another way you can also organize things as well. You can actually name these parts if you need to. So call it 555 timer. And there's a variety of different options, so you can actually change the font and the font type if you need to. Another thing on top of all this is that if the wires are just there's way too many wires, what you can also do on top of all this is actually you can also color code them. So if you go ahead and go to right click and hit net color and go to custom, you can actually select what color you want. So in the case maybe for pin 7, I'll make it purple. So now it's purple, so that it's another way of organizing things as well. And I can go ahead and color the ground wire as well. So I'm going to go to net color. I like coloring my ground wire green, so I'm going to go ahead and do that. So now everything is green. And in fact, you can go ahead and see that with all the other parts as well. So everything that's connected to ground is now, the wire is now green. I can go ahead and do that with power as well. So what I can do in this case is, unfortunately, what you have to do when it comes to this, you actually need to go ahead and connect this to some arbitrary wire. So I'm going to go ahead and do that. Say it's arbitrarily connected here. Actually, no, that's not a good idea. Let's go ahead and not do that. Control Z. We'll just put some random part down. So just put an LED down and say it's connected to that. And then say it's connected to power. So I'm going to go ahead and say power. Yes, go ahead and do that. So now it's connected to power. I can now change the color, hit custom. I'm going to make this red. There, now power is red. I'm just going to go ahead and delete this and say that this is now connected to power. So now all the powers are red. If I want to say, use different colors for the control voltage, I can go ahead and do that. So I'm going to use, I'm going to just use like a blue for that. For trigger, I'm going to go ahead and connect this and make the color, say, orange. And then, yeah, now you have a very, very colorful schematic. And you can do that with every wire if you need to. All right, so with that in mind, let's go ahead and just make the PCB, because that's what we want to do, right? All right, so to make this PCB, we're going to go ahead and go to File and hit Convert to PCB. So what it's going to do is it's going to transfer all your parts onto the PCB layout part of Diptrace. And it's going to ask you if you want to use the schematic rules or the previous ones. Just use the schematic rules. Okay, so here are all your parts, and you can actually move them around. And you can also organize them up. So this is actually how you make the PCB. So one thing to keep in mind on top of all this is you want to make sure that you follow design rules. So you can't make your traces super duper thin because your manufacturer might not be able to do that. So you want to go ahead and check with your manufacturer that you want to use if it follows their design specs. So what we're going to be using is we're going to be using OshPark. So OshPark is a very, very cheap service. They do things at like it's $5. I think it's like $5 per square inch. You can get 3 copies of your board for that. It's very, very cheap. But the problem is it takes 12 days to have your part come in. So that's a little side consequence for them. And here are their design rules. Here are just the file formats that they need to have. Here are the design rules actually. So right over here you can see that there's a 6 mil minimum trace width, a 6 mil minimum spacing, 15 mil clearances from traces to the edge of the board. So before I get ahead of myself, so mil, what does that mean? Mil is a measurement. It means millionths of an inch. So if you work with American manufacturers, they typically still work with millionths of an inch as opposed to millimeters. So millimeters is commonly used by European manufacturers. So just mil is just a kind of a go-to that people use if you're manufacturing this from America. So again, here's just another thing as well. 13 mil minimum drill size. So the your holes must be at least 13 mils or larger. 7 mil for the minimum annular ring. So an annular ring, let me go ahead and show you what an annular ring means. If I go ahead and place a via or pad, I can actually put that right there. So you can actually see this is this is a plastic, this is a piece of metal. The annular ring is this black area right here. So you want to go ahead and make sure that this is like 17 millionths of an inch thick. So you go ahead and right click and go to pad properties, then go to patterns pad properties. You can see that the width of this is actually the outside diameter and the hole is the inside diameter. So as you can see, if you subtract these two, this is actually like 24, so it fits the design rules. So that's okay. but you have to make sure that the diameter, the width of this must be or the width and height must be 17 mils greater than the diameter. Just to keep in mind. Hit OK, and I'm going to go ahead and delete this. All right, so with the consideration design rules in mind, there's actually a design rule checker on this. So let me go ahead and show you just how it works. If I go ahead and just move this close over here, what's going to happen is it's going to show red to indicate that I'm violating design rules. And this is the the real-time design rule checker. That's an option you can have. So to do that, go ahead and go to verification, go to design rules, and you can go ahead and set all your design rule considerations in mind. You can go ahead and enable and disable the real-time design rule checker. For the sake of this tutorial, we're going to go ahead and keep that enabled. And these are just distances that you need. So this is the clearances of each part. So each part is 6 mils away from each other. So I went ahead and just set this all up. The distance from the board to anything is 15 mils, so I went ahead and did that as well. And you can go ahead and edit a few other things as well. You can go ahead and just look through these. You can go ahead and change when you want to actually do the design rule checker, the real-time design rule checker here as well. But I just set all these options because it's just really nice to have. These are also other options if you want. It'll also do some other checks. So you want to go ahead, if you can do this, you can go ahead and do check the silk screen over pads, check the same net pads, check the jumper wires, check route keep outs, all these other things as well if you want to go ahead and do that. So I'm going to hit OK. And so with that in mind, you can actually see that all this is garbled up. You can go ahead and drag, you can go ahead and left click and drag and drop these. And you can also hit spacebar if you want to rotate them, just like we did in the schematic editor. But another thing you can keep in mind is you can also go ahead over here and hit placement. Then you can do run auto placement. And what I'll do is actually put it all up together in a very somewhat organized fashion. Now there's another thing you can keep in mind. To actually put a wire, they call these traces. You can use this one option called route manual. You can click that, and what you can do is, and you can go ahead and select one of these, metal pieces, and go ahead and click it. And as you can see, it's going to go ahead and map to the closest pin that needs to be connected to. And all these blue wires are, these are called trace, not traces. These are called nets, and they indicate what needs to be connected to what. So I'm going to go ahead and just do it right here. You can see that I now connected this over here with a metal copper trace. And you can see this is very, very thin. You can go ahead and right click this, and you can actually change the width. So you can change the trace width, and you go ahead and hit custom, and use 15 mil. You can also create templates if you want, but we're not going to be doing that. So now this is slightly thicker if you want to do that. Okay, so I'd like to also keep in mind that there's a thing called auto router. So if you want to go ahead and go to route, there's this thing that you can use that'll automatically route all this stuff together. But it's highly recommended that you don't use this because sometimes it doesn't really understand what you're trying to set up. And when you make more advanced designed PCBs, sometimes the auto router doesn't understand exactly how it should all be set up. And sometimes it doesn't take into account the real world considerations as well. So if you do advanced PCB design, there's like for instance, there's this one example where you want to make sure that all your analog components are separate from your digital components, because your digital components could actually cause magnetic interference of your analog components. So that's another thing to keep in mind. So you want to make sure that all the traces that are connected to analog components are separate from the ones that connect to digital components. And so auto router doesn't take that into account. But in the case with this, let me just go ahead and show you how this runs. So I'm going to hit run auto router. It's going to go ahead and try to create all the connections up. And as you see, it violated one of the design rule considerations right here because it couldn't fulfill it. And also created the board outline that we're going to be creating later. But I'm going to hit Control Z, and we're going to do this manually because I think it's best to do that, because just to show you everything that Diptrace can provide when it comes to routing things manually. Okay, so before I get crazy, there's another thing to keep in mind is that this is the top layer that you're seeing. So there are two layers on this. So there's the top layer and the bottom layer. If you want to go ahead and change the bottom layer, you can go ahead and go over here and hit bottom, and it'll show you the bottom layer, and it will mask everything that's on the top. You can also on your keyboard, you can press 1 to go on top and 2 to go to bottom. So I'm going to do that because it's very convenient. So 2 is bottom, 1 is top. And the other thing to keep in mind as well is you can also delete nets if you need to. So if you need to there's this one that's a rip option. Or actually, you can place more rat lines if you need to. So these are called rat lines. If you want to go ahead, you can go ahead and connect this as well. Another thing to keep in mind is that on top of all this, there's also the option of, say you wanted to add one extra component over here and you didn't have it in your schematic. You can go ahead and place component. You can add whatever component you want if you need to. So I can go ahead and just grab, say this part right here. I can actually move it over here if I need to. And go ahead and delete this though, because that's not the best way to do things. What you can actually do instead is you can actually go refer back to your schematic, and if you want, you can add a part to this. So let me just say, I'm going to go ahead and arbitrarily add some sort of diode, a diode over here. Hit diode. Okay, so there's going to be a diode now in the schematic, and what I can do now with this is I can go to File, and then go to Renew Design from Schematic by Components, and if I go ahead and select my file. So this is a 555 timer 1. It'll go ahead and figure out what's missing from it and add that part if necessary. It didn't seem to really add that. Let me see. What is the name for this one? Oh, sorry, because I didn't save this. Let me go ahead and save this and call this 555 timer 1. Well, timer 2, because I made another timer circuit previous to this. So actually go ahead and go to File, then go to Components, then go to 555 timer 2. It should add the diode. So there's the diode right there. And if you actually, on your schematic, if you actually wire this to any other part right there, and you actually update it, actually create the rat line according for that. I'm going to go ahead and delete this. There we go. Okay, so we now have all these parts. Let's go ahead and connect this stuff up. So I want to put this one right here, because it's close to these two parts. I want to go ahead and connect this right to here. And another thing to keep in mind is that you can also organize these rat lines if they get a little bit confusing. So you can go ahead and go to View, then go to Rat Lines and hit Optimize. You can also hit F12 if you need to. It'll go ahead and optimize the rat lines. And as you can see, it's already optimized already, so it didn't really make too much changes. Okay, so this one needs to be connected to this part right here, and this part. This needs to be connected from here to here. Oh, another thing to keep in mind on top of this, if you want to go ahead and change this to the bottom side, you go ahead and right click and you can change side right here. So it'll flip to the bottom side. Hit 2 over here, then it will actually highlight itself. So that's another thing you keep in mind as well. So you want to make a more optimized design, you can always use the bottom as well. So I'm going to go ahead and just arbitrarily just put this on the bottom just for the sake of it. So I'm going to put it over here. Okay, and then we're going to go ahead and move components accordingly. You want to try to make the smallest design as possible because that reduces your cost of your circuit board. Because the way that the ordering works is that it's based off your square inches that you use. You put that over here. This one needs to go. I'll put this on the bottom. And then this one will need to go right here. So go ahead and just move things around if you need to. I'm going to go ahead and just wire everything up because it seems like it's pretty okay. Actually, I put it right here. Okay, so that should be all right. So let me go ahead and just wire things up. So I'm going to go ahead and click this, Route Manual. Okay. Click, click, and then click here, click here. And then if you want as well, let me just go ahead and optimize the rat line right here. There you go. You can also change exactly how you want to have this all angled up. So if you go ahead and go to current segment, you can change it so that it routes to a different format as well if you need to do that. So this one will go like this in direction. You can actually change this to a variety of other options. A free line will actually, you can go ahead and just move it around to whatever you want it to be. You can go ahead and also change this to other variety of options. So 3-point arc, you can also make this if you want. You can do this curvely. You can actually make curved wires if you need to do that as well. You can go ahead and play around with this, and there's a variety of different options, but I'm going to go ahead and use the 90 and then the 45 for this case. And again, if you want to make these thicker, I'm going to go ahead and make these thicker. So I'm going to go ahead and go to net width, custom, 15. That'll make everything thicker. I'm actually going to go ahead and just delete this one. So you actually don't want to use delete. You actually want to unroute the trace. So that'll fix things up, and you'll still have the rat line. So go ahead and just connect it like so. We're going to go ahead and make this one thicker. So change the trace. Oops. Change the trace to 15. Change this to 15 as well. Change this to 15 as well. Okay, this is a little bit too close for my comfort, so I'm going to go ahead and move this down a bit. And that should do it. Okay, so what we now have is pretty much our board all set up. Now what we need to do on top of this, we actually need to make a board outline. So let's go ahead and do that. So over here, you can actually click this to place the board outline. And you go ahead and click on one end, and then you can go ahead and click on the other end. And you just make four sides for this. So go ahead and select here. Then we'll select right here. Go ahead and scroll up right over here. And go ahead and set it over here as well. And that should be it. So that's our board size. This is slightly a bit angled a bit. So I'm going to go ahead and click this, and I want to adjust this. So this should move it. Move this slightly down a bit. And that should be it. So that is our board outline. And what we want to do on top of this now is actually make a ground plane. So the ground plane, or the copper pour is what people like to call it, is a great way to actually cover the rest of your circuit with ground copper. So this is copper that's connected to ground. The advantage of this is that in the case with radio frequency systems, this helps to actually protect the rest of your circuit from magnetic fields or any sort of like radio frequency, so it helps to prevent it from any sort of noise interference. So we're going to go ahead and do that. Another thing to keep in mind is that the advantage of this is also makes it so that you can go ahead and easily connect anything to ground if you need to. So I'm going to go ahead and click this. Then I'm going to go ahead and select one end, and again do the exact same thing that we just did previously, which was connect, make a four-sided board. Okay, go ahead and finish this up. Okay, so now once you finish the copper pour, what's going to ask you now is just a few little design considerations. I made the clearance to be 8 mil, so that meets our specs. Island removal, so this is just in case if when it covers it up, it doesn't actually connect to anything. So this is just a check to see if if the minimum area of that chunk is greater than this, then it's okay. If it's not, if it's too small, then it'll be removed. Connectivity is what this little copper piece is going to be connected to. So we want to go ahead and set this connect to ground. Okay, so and the spoke width is just a space between the other things, and then that should be pretty much it. Go ahead and hit OK, and let's go ahead and cover everything that's ground. So this black thing is actually a metal, and if you want to go ahead and unpour it, go ahead and hit state and hit unpour, so it won't cover anything as well. But another thing you could also do on top of all this is you can also color code things just like we did in the schematic, which I like to do. So if I go ahead and go to power, right click, we can go ahead and set net color. I want to go ahead and set this to red. So now everything that's connected to power is connected. You can actually see what's connected to power or not. Right over here, let's connect things to ground. So let me go ahead and set here. This is ground. Let me go ahead and change that color. So right click this, hit net color, go to custom, and we're going to go green. So green is now ground. And as you can see, if I go ahead and fill this up, hit poured, you can see that everything that's green is ground. I can do this with the bottom as well, so I just hit 2, so now I'm on the bottom, and go ahead and do the copper pour again, Okay, so do 4 sides. And then we're good, and it's going to go ahead and ask you the same thing. Go ahead and make this connect to ground. Hit OK. And yeah, okay, so that's pretty much it. There's going to be one capacitor on the bottom, one resistor on the bottom, and all the other components are going to be on the top. And another thing to keep in mind on top of all this, the fun part about Diptrace is that you can actually see this in 3D if you want to, as a 3D model. So if you go to its view, and then go to graphics mode, not graphics mode. Just forget this. So this is going to cut this right here, and we'll go ahead and, with the previous one, with the previous part of the video, we'll splice it to this one, is what we're going to do. There we go. Okay. Stop right here, reset. Okay, so we just finished this setup. So another fun thing that you can do with Diptrace, you can actually see what this looks like in 3D. So if you go ahead and go to Tools and go to 3D Preview and hit 3D Visualization, you can actually see what it is. So it's going to go ahead and load this thing up. If it doesn't do this, what it's going to do is it's going to ask you for a program that you can download on Diptrace, the website. So if you go to Downloads and you go to Libraries and Updates, you can go ahead and download the software that you can actually use to export this into a 3D format, and there we go. So this is what the circuit looks like in 3D. And if I go ahead and rotate this accordingly, I can actually click this and move it around to see what it looks like. Now this is the part that we used. So this is the one that has the little pins on the side that actually exports this out. But this could be anything if we wanted to. This is just an arbitrary selection that we did. And you can see this is the capacitor, these are the inert capacitor. On the bottom is an inert capacitor as well. Here's a resistor. Here's the the LED is right here, and the 555 timer is located right here. And if you want, you can go ahead, if you're using SolidWorks for your project, you can go ahead and export this into a step file and actually import this into your SolidWorks image, and actually put this into your device and actually make it look like you actually have a circuit inside. So that's a little fun thing you can do with this. I'm going to go ahead and close this, and in the next video we're going to go ahead and cover exactly how to export this into a file format that the manufacturers will actually use.